Hi folks, we're back to finish up lecture 4, dimensional analysis. Here we're going to be talking now about dosage calculations. And to motivate this, I wanted to start with the 5 rights of medical administration. So maybe you have encountered this before or you will, but this list is a starting point to think about safety for your patient and to reduce harm. So when working with a patient and giving medical administration, you want to think about always checking that you have the right patient, the right medication, the right dosage, the right route, and at the right time. These are all obviously very important rights to remember, but I put a little note down here that the 5 rights should be accepted as the goal of the medication process, not the end all be all of medication safety, right? So just doing this is not enough, but this is a really good start. So right in the middle of all of this is the right dosage. And so you might need to calculate that. And that's what we're going to focus on now and often in the future. So dosage calculations. You might, as a nurse, be given an order of something like this: 8 milligrams of tetracycline per kilo body weight, QD. Whoa, what does that mean? Okay, so 8 milligrams per kilo. Notice the per, right? We have a ratio, and we have basically the amount of drug per amount of body weight. This is a conversion factor, right? This is definitely something that you will now think of as a conversion factor, right? Converting between the mass or volume of the drug that you need to give and the body weight of the patient that you need to give it to. So you will write a actual ratio, something like this: milligrams of drug over kilograms of body weight. Now, depending on the question and what you're trying to do, remember, if you had to, you could flip this, right? Maybe you know how much drug was given and you have to figure out what the body weight should be or was of the patient and make sure it's like connecting. So you would, it's a conversion factor, so you can flip it and always do it the other way. In this particular question, 8 milligrams of tetracycline per kilo body weight QD means that a dosage of, or it indicates that a patient should receive 8 milligrams of the drug per each kilogram of body mass in a 24-hour period. So a couple of abbreviations: QD or BID. QD would be once a day, right? So the entire 8 milligrams per kilogram one time a day. Or BID would be twice a day, divide the total amount by 2 and give every 12 hours. Okay, so let's actually look at a real problem and then do it. So figuring out how much medication to give to your patient. The daily dose of ampicillin for the treatment of an ear infection is 115 milligrams of ampicillin per kilogram of body weight. What is the daily dose in milligrams of the drug for a 27-pound child? So let's make a unit plan first and always consider significant figures. Okay, so making our unit plan, remember that's like, what do we have and where do we want to go? So our starting point is pounds. We're given the weight of the child in pounds. We want to get our desired result in the end is milligrams of drug. And so is it just directly we have a conversion between these two? We do not directly have a conversion between these two. But if we look at the dosage, we can use kilograms as an intermediate. a single step conversion to kilograms and then to drugs. So kilograms of body weight. I'm going to have pounds of body weight. And now we can make this first connection and then this second conversion. Okay, so that's our plan. It's our map. Now remember, each arrow represents a conversion factor. And so the first one will be from pounds into kilograms. So 1 kilogram equals 2.205 pounds. You can look that up somewhere in a table from the previous slide or in your textbook. And then we can write this as a ratio, right? And in this case, we want kilograms on top because we're converting into kilograms. And then this arrow represents the conversion factor. And that's going to be just the connection between drug and body weight, which is the dosage, the daily dose, right? So that's going to be 115 milligrams of drug per 1 kilogram of body weight. All right. Once we have our unit plan, we have our conversion factors, then we can set it up and calculate. So we always start with the known measured quantity, which is 27 pounds, and then multiply by our conversion factors. 1 kilogram over 2.205 pounds times 115 milligrams of drug per kilogram. Pounds divided by pounds, kilograms divided by kilograms, and we're left with milligrams. So if you plug these numbers into your calculator, 27 times 1 times 115 divided by 2.205, and we get 1408.16 milligrams. Okay, but you're not going to measure out that precisely, right? Let's think about significant figures. All right, so the amount of the daily dose or the medication, the dosage is given here. It's 115. How many sig figs does this number have? That's 3, right? The weight of the child is given as 27. That only has 2. Additionally, our conversion factor here has 4, right? So the limiting is the weight. If you only know 27 pounds, then we only know it to within 2 sig figs. And so 1408.16 needs to be rounded to 2 significant figures, which would give us an answer of 1400 milligrams. Now remember, these zeros are not significant, just the 1 and the 4. All right, let's move on to a similar but different question. All right, the antibiotic zithromycin has been prescribed at a dosage of 30 milligrams per kilogram QD for an 8-month-old infant weighing 18.2 pounds with an ear infection. How often should the drug be administered? Okay, so no calculation yet, just reading this question. What does it all mean? Okay, so the first thing that we're going to look at is how often, right? At the right time and the right frequency. And QD means once per day. Now, same question or same information, but the question is, what is the daily dosage? So 1 time a day, how much are you going to give? Okay, so we actually have like the same kind of information here as the last question, just the numbers are different. So our setup is essentially identical, but let's just walk through it all again anyway. So we have a dosage given is 30 milligrams per kilogram. We have the infant's weight given as 18.2 pounds. And when it asks what is the daily dosage, that means what are we trying to calculate? I want to know the milligrams of drug. So we can go pounds of body to kilograms of body to milligrams of drug, just like before. So here our conversion factor from pounds to kilograms will be 1 kilogram over 2.205 pounds. The second conversion factor will be 30 milligrams per kilogram. And when we put it all together, 18.2 pounds times 1 kilogram over 2.205 pounds times the prescribed amount, 30 milligrams per kilogram, pounds divided by pounds, kilograms divided by kilograms, and we are left with milligrams. And I plug it into my calculator exactly like this, and I get 247.619048 milligrams, which is not one of my options here. Well, that's because we don't actually want all these numbers. This would be rounded, and the only option that fits is 250, which is actually 2 sig figs. So to be picky here, this number must be 30 dot. Remember, the dot means that the 0 matters. So if we only had 1 sig fig, it would have to be 200 or 300. But we'll go with the options available here, and the answer would be D, 250 milligrams. All right, so these two questions were essentially the exact same setup because that's going to be the most common one you will encounter, right? It's like here's the prescribed dosage, milligrams per kilogram. Here's the weight of your patient. How much do you give them? Okay, so that's a calculation that you should be able to do with more practice quickly with the following the pattern. But notice that we can ask any other combination of question like this, right? Like given that you gave this much to the patient, how much must the patient weigh, or how many pounds? You know, you can go in backwards as well. So the last slide for today is kind of a fun one, just to think about multi-step conversions. And I would ask, how many seconds old are you as of your last birthday, right? So think about how would you set up, like given years, right? Maybe you're 18 years old, 19 years old. I'm 36 years old. How many seconds old am I? Well, I'll let you figure that out for yourself, how old you are, but think about a unit plan, something like maybe years to days to hours to minutes to seconds. Or, you could do months or weeks or whatever order, you can do something different if you would like, get to a similar answer. Are you going to take into account leap years, or how much precision is your final answer going to have, right? So it's kind of a fun thing just to think about how you would set this up. And talking about doing it in reverse order, let's say how many years will you be when you're 1 billion seconds? 1 billion seconds old, right? Have you passed that threshold yet? Find out, right? So you can go the opposite direction, go from 1 billion seconds into how many minutes is that? How many hours? How many days? How many years? Right? And so filling in conversion factors for each arrow between the sides of it, you can solve that. All right, and I'll leave that as a fun thing for you to do on your own. All right, this wraps up lecture 1-4 about dimensional analysis, but we will continue with these skills over and over again as we move forward. All right, don't forget to post lecture question, and we'll see you next time.